Okay. Very good morning to all of you. Let us join quickly, and we will see how to start. We'll wait for a few moments, like people will be joining in. Then we will start with this. Our exact differential equation journey will continue now, and we will be beginning with the cases when the differential equation is not exact and how to handle that. So let us see those kind of cases, that how to handle the differential equations when they are not exact. We got this thing, options are there. Okay, right, like I'm using this now. um, yeah, so let us start now with this exact differential equation. So before I move on to the journey of exact non-exact differential equation, let me just give a quick recap of what is to be done. So yeah, so exact DE, exact DE, when we are writing, yeah, we have this with us. What do we have in exact DE is we have a differential equation mx comma y plus mx comma y dx plus nx comma y dy is equals to 0. Okay, then this is the differential equation, and this one is exact DE if dabba m by dabba y is dabba n over dabba x. Okay, this is the condition it should satisfy, and solution, or the general solution of 1 is given by integral m dx, where y is constant, plus terms of n free from x dy equals to c. This was one formula, and then we had an alternate version also, or you can write, I'll take here, or you can use integration terms of m free from y dx plus x constant integrating n with y. Okay, this is another version of the formula that you can have. Oh, good morning. If you are joining a little bit late, do post in the chat. I'll be happy to see you in the chat. So these are the this was the fundamental thing that I did yesterday. We did few examples on this, and now we are going to see uh, some examples on non-exact differential equation. So what happens in the case of non-exact differential equation? Let us see. What enters into the picture is something called as integrating factor. So now m x comma y dx plus n x comma y dy equals to 0 is a differential equation such that dabba m by dabba y is not equal to dabba n by dabba x. Okay, then we find that there are four cases now. So what are then four cases? Then we find integrating factor, and we will see what is that. Then we find an integrating factor if. Okay, in short it is written if. Okay, we find an integrating factor. So there are four cases in our we are going to see over here, which is as follows. So case number one, case 1. What is case 1? Let us see. First case, you keep the numerator same all throughout, dabba m by dabba y minus dabba n by dabba x. When you have this case, okay, and you divide by capital N, you keep this numerator and you divide by capital N, you must get a function which is a function of x alone. Okay, you must get a function of x alone. So then if is e to the power integration of f of x dx. Okay, this is the if. This is if we get over here. This is the formula essentially that we get in this case. Good morning to all of you, those who are joining little late. Maybe it is difficult on your end, or maybe you have not you are not aware. I'm starting with non-exact differential equations and how to make them exact. Okay, so that is the case here we are dealing with. Now then there is case 2. So case 2 is same numerator, you keep same numerator, there is no harm. You have dabba m by dabba y minus dabba n by dabba x, no change, and divided by minus of m, and you must get a function of y alone. Okay, when you get a function of y alone, in that case what you do, then your if is e to the power integral g of y dy. Okay, these are the two most important cases. Then there are others also, we will see them also. As I said, there are 4 cases we are going to deal, so we write them here. Now then there is case 3. So case 3 is slightly what you can call, it's slightly different in nature, but I would say that you can try whichever method, it is slightly flexible in understanding of the whole process. So case 3 you can take this way. um, let say, suppose that suppose that we have differential equation of the form y multiplied by f of xy, okay, dx plus, okay, plus x multiplied by g of xy, some function, I don't know, they can be any function, and dy equals to 0. Now, and we need one more thing, and uh, here we let what you can say, this is your m, okay, so here let m equal to y f of xy and n equal to x g of xy, okay. Also you must get this x into m minus y into n, okay. X into m minus y into n is not equal to 0. It is not equal to 0. Then we have if the integrating factor equal to 1 upon xm minus yn. This is the integrating factor. Now case number 4. Now this case 4 is something really simple and easy, but then since it is there, I would just give you, otherwise you can do this straightforward also. Suppose that m dx plus n dy equals to 0 is a homogeneous differential equation. Okay, suppose this is a homogeneous differential equation and xm plus yn is not equal to 0. This happens, then integrating factor, then we have if equal to 1 upon xm plus yn. This is the integrating factor you have. Now here this is pretty much optional, okay. Let me tell you that this is optional case, I would say, but though it is there in the sorry, in the syllabus or in the portion to be dealt with, I can tell you sorry, that if m dx plus n dy is homogeneous, this can be also solved. This case can also be solved by homogeneous DE method, that is we can just put y equals to Vx. Okay, you can just put y equals to Vx and this will work, this should work. Otherwise there is no point in saying that it is a homogeneous, because already in our plus 2 level we have seen how to solve a homogeneous differential equation. So unnecessarily I don't think so there is a need to pile up a method or something like that. So let us see now examples. Yeah, but what do we do after finding if? Before even just jumping on to the solving of the example, let me tell you what to do with if. So after finding, here we will write after finding if, we multiply the if to the given differential equation. Okay, we multiply the if to the given differential equation m dx plus n dy equals to 0, so that the new differential equation m1 dx plus n1 dy equals to 0 is exact dE. Okay, so we call this equation number 3. Now what is m1 n1 is exact dE. Here you can write here m1 is if multiplied by capital M, and n1 is if multiplied by capital N. This is what is m1 and n1 is exact dE, and hence we find the solution of new dE, new exact dE rather, okay, new of new exact dE. This new exact dE 3 in similar manner. Okay, so this is what the process is. Now let us see how to do some questions related to each of the type, and let us handle them carefully. Now I hope you are clear with the process. The process is going to follow some steps that you are going to be given a differential equation. And later on, what we are going to do, hello, um, hello, we have one viewer there. Hi. uh, yeah, a very good morning. So here we are going to do the solving now. So see, when you do m this non-exact differential equation, be very careful with the cases, because what is going to happen in exam, that you will be given differential equation and it would be straightforward written solve, nothing else. We won't know whether it is exact or something else. Okay, this is very important to understand, that we won't get to know what type of differential equation it is. So we have to be very quick in checking whether the differential equation is exact or non-exact, and if it is non-exact, then which of the four cases it will fall. So let me show you how to handle this, and you don't have to be confused while solving. If you get confused, then you will get into trouble. So let me help you out how to come out of it, of understanding the question first carefully. Now, the most easiest way to understand the differential equation, whether it is exact or non-exact, how to get it done. So let us see some simple question now. Let's take up this. Solve xy cube plus y dx plus 2 times x square y square plus x plus y raised to 4. Okay, this is the question that it is given to us. We are taking up this one. Now, while solving this question, we have to be very careful. First, we will write here the differential equation. Always have a habit of writing the given question again. Given dE is xy cube y dx plus 2 x square y square x plus y raised to 4. Then now this statement is not required, but if you write it is okay. It's of no harm. I'll just write here in blue, comparing with m dx plus n dy equals to 0. Okay, there is no harm in writing this statement, but it is, as you gain the proficiency, you become a little bit pro kind of in differential equation. You can skip this blue line. Okay, but if you are initially just developing the skill to solve the differential equation, then you may need this to write. So this is your dy equal to 0. Okay, so now, so therefore m, when you compare, what do you get is xy cube plus y, and n you get is 2x square y square plus xy whole raised to 4. This is what you get. Now we check whether dabba m. First you check that dabba m by dabba y, whether it is coming a good answer or not. That is also very important. So what do you do here? You take the derivative. So it is 3xy square plus 1. This is the derivative. And what is the derivative for dabba n by dabba x? 2 remains outside. Then you do again the derivative. So it is 2xy square. X derivative is 1 and y raised to 4 derivative is going to be nothing, right? Y raised to 4 derivative is 0, so it's gone. So on simplification you get this 4x y square plus 2. Now when we solve this further, we get dabba m by, obviously you did not even say, otherwise let's do this here. For the first question we can say here that dabba m by dabba y is not equals to dabba n by dabba x, okay, which implies that 1, we label this as 1 is not exact, DE is not exact D, or it's a non-exact differential equation. So therefore we first now consider dabba m by dabba y minus dabba n by dabba x. You get this quantity first confirmed. You confirm this quantity in any case. Dabba, the one which we have seen, we have got the 4 cases. In the 4 cases you consider this quantity as a first case, okay. Like this is the thing you go before even finding the cases, which cases is there, okay. Now so dabba, here we have 3xy square plus 1 minus, when we have this one 4xy square plus 2, so you do that 4xy square plus 2. On simplification what do we get here? It is, we get here is, yeah, we will get here so minus of x y square, and we'll get minus 1, right? That is what we will get. Now comes the thing, how do we handle it? Yeah, this is what we have to do. Now which term we should divide this so that we get a nice answer? That is the place, sorry, that is the place where the whole story starts. Now we can do a bit rough work, or we can just by mere observation we can get the answer. See, we have two options, either we divide by n or we divide by minus m, okay. So on dividing by n, it is very obvious, n is a big term, it's a multinomial over here, so x raised to 2 y raised to 2 plus x, it's not going to get simplified. But here on m we can clearly see that we can take y common and we can get some answer, so we divide by minus m over here. So therefore dabba m by dabba y minus dabba n by dabba x divided by minus of m. What do we get here? We will get minus xy square minus, here xy, I'll just write this correctly, xy square minus 1 divided by, what is m? M is minus, here we have to take x, we are already putting a minus sign to that, so here we will get minus of xy cube plus y. Now when we simplify this, that minus sign from the numerator and the denominator gets cancelled, or you can, if you want, you can show like this, and you can take y outside, so minus of y over xy square plus 1. This you can see that it is clearly getting cancelled. So you cancel that off with the minus sign and you get your answer as 1 over y. Okay, so we got our function in terms of y. Okay, so this is g of y. Therefore, integrating factor if is equals to e to the power integral g of y dy. It is equals to e to the power integration 1 over y dy. Now, remember, integration of 1 over y is log. Okay, it is log of y. Now you have a very wonderful property from logarithms coming into the picture, that is a to the power log of x to the base a is x again. So if you use this property, okay, then you will get your answer here as y. So this is the if that we got. Now we multiply this if to the given differential equation. So multiplying if to 1, what do we get when we multiply? We will get y into xy cube plus y dx plus 2 into y x square y square plus xy plus x y raised to 4. Okay, and then there is dy equals to 0. So this is our second differential equation, or we can even simplify this a bit more and then put a second to it. Okay, so what we will get now, we will get here y, you multiply here, so it is x y raised to 4. Okay, then there is y square dx, then here you have 2x square by cube plus 2xy plus 2y raised to 5 dy equals to 0. Now we compare here, so therefore we now compare, these are again, it is of the form m dx, but now we have already used m as a alphabet, so we will compare it with m1, right? So you can write here if you, again we can use this, comparing with m1 dx plus n1 dy equals to 0. So what do we get as m1? We will get our m1 becomes x y raised to 4 plus y square, and n1 becomes 2x square y cube plus 2xy plus 2y raised to 5. Okay, this is what it becomes. Now we check whether this is exact or not, because sometimes when you multiply, the differential equation may not look exact. Okay, may not become exact, but as a theory says it becomes exact. But some differential equations are tricky, some give you different answers, some do not behave very nicely, so we must always check also. So dabba m1 by dabba y. So now let us do the derivative of this with y. We had here x y raised to 4 plus y square, so 4xy cube plus 2y. Okay, and then dabba n1 over dabba x. So the derivative when we have to do, we will go for the next the new term that we have got n1. It is 2x square y cube, the two, yeah, 2x square y cube plus 2xy plus 2y raised to 5. Now when we do the derivative over here, it is 4x y cube, and then here it is 2y. Yeah, so therefore dabba m1 by dabba y is equals to dabba n1 by dabba x. Okay, so we can now claim here that this equation 2, hence equation 2 is an exact DE. You can say that. This is the claim that you can do. Now let us see how to handle the solution. Therefore, general solution of 2 is integration m1 dx, treating y constant, plus terms of n1 free from x, dy equals to 0. Oh, so not equals to 0, you put c. Okay, we are in the general solution mode, so it will be a constant. Okay, so now while writing the solution, we will have integration. Therefore, integration y constant, we'll substitute the value x y raised to 4 plus y square, okay, dx plus terms of n1 free from x. Now there is nothing in the first term free from x, and here also nothing is free from x, but 2y raised to 5 is free from x, so we take that. Dy equals to c. Now let us see what happens. So solution over here is x square y raised to 4 over 2, okay, plus y square is constant, so you have x there, and here you will have 2y raised to 6 over 6 equals to c. So on simplification, you can either take the whole thing on the other side, you can take LCM and do, or you can just simplify and keep, nothing will go wrong. So x square y raised to 4 over 2, I'll just simplify and keep it the way it is, not a problem, and y raised to 6 over 3 is equals to c. Okay, is the required solution. Okay, so this is the first case. On this we have seen that how does this work. Okay, so I hope you have followed this example very nicely, and we will be now seeing the next example. So let us see one very nice example which is always there in most of the examinations, and it sometimes bothers students how to handle this on M. Okay, so we'll take up a example quickly. That is, they have asked us to solve the question here, that is y over x sec of y minus tan y dx plus sec y log x minus x dy equals to 0. So in answer we will write our differential equation again. So we say given dE is y over x sec y, okay, sec y into, here it is into, okay, tan y dx plus sec y log x minus x dy equals to 0 is 1. Now m is over here is y over x sec y tan y, and n over here is sec y into log of x minus x. So the moment I do dabba m by dabba y, what I will get here? Oh, here there is minus, sorry. There is a minus sign here. So here there is a minus sign. Okay, so we'll just write this properly. Yeah. Tan y. Okay, now when we have to do the derivative over here, so y sec y, 1 upon x is constant, so it will stay outside. So y into sec y, the derivative of sec y is sec x tan x, right? Sec x derivative is sec x tan x, so sec y derivative will be sec y into tan y, and tan y derivative is sec square y. This is what we get. And here you will also have a product rule coming into the picture, right? So let me do it again. I'll erase this. I'll just do this again here. See, when you do the derivative over here with y sec y, there will be a UV rule applied. So UV rule, when you apply, so UV rule is basically in partial derivatives also there is a UV rule, but it follows the same conjecture. The same notion is there, uv dash plus vu dash. Okay, so what you do is here what you will get is y sec y tan y, okay, and then there is sec y outside and into y derivative, so you get 1 over here. Okay, this is the derivative of the first portion, and tan y derivative is sec square y. That is what you get. Now dabba n by dabba x, when you go for doing this, so sec y is constant. Okay, so when you do derivative of sec y into log x, you will get sec y as a constant outside. Log x derivative is 1 upon x, minus of x derivative is 1. Now you see that nothing is getting constant, but then something should get cancelled over here. Then let us see what gets cancelled, or some term must give us some proper answer. So dabba m by dabba y minus dabba n by dabba x. When we do, This is equals to, let us see what quantity we get. 1 over x into y sec y into tan y. Now this 1 over x will be multiplied, so it is 1 over x sec y, okay, minus sec square y over x, and then there is this minus here, so minus of sec y over x plus 1. Now on simplification we see that this will get cancelled, and anything else getting cancelled, let us see. Nothing else is getting cancelled, right? Now when we want to do some further simplifications, what can we do now? So we have to divide here by minus of m. So be very careful while doing this, because we have these terms there and we have to settle those terms carefully. We need only a function of this term, right? So let us see how to handle now. So we divide this term by m. So on dividing by m, minus of m rather, so by yeah, I'll write this thing behind better, it would take me. Let us write it here. Let us write this here. Dabba m by dabba y minus dabba n by dabba x. When you have, how much do we get? It is y by x sec y into tan y. Okay. And then there is minus sec square y over x. Then there is plus 1. Okay, these are the terms that we are left with. Now we are dividing it by minus of m. Okay, minus m we are taking, and minus m when you do, so m here it is minus sign, and m is y by x sec y, and tan y is there minus tan y. Now we need to handle this very carefully. Okay, whoa, something got cancelled, and yeah, 1 by x sec square is there, and yeah, this 1 by x is not to all, right? Yeah, just a minute. Here we have this bracket is not till here, it is only till here. Yeah, so this is only till this much. Yeah, this much is the bracket. So yeah, that it goes only, so this x won't come. Yeah, this is what we have. We have to be very careful when you put the bracket also. See, so this is not there. Yeah, so While doing the cancellation, we got these terms, and now we will see how to handle it. Now 1 minus sec square and everything is there, so we'll put this minus sign up. We put this minus sign up first, so what we get is minus of y over x sec y tan y, and then there is plus sec square y minus 1, and then here you have minus, this minus is gone, okay, so y over x sec y minus tan y. This is what is left. Now what do we do regarding this? Okay, so see, we sec square minus 1 we have here, so it is basically we need to now write the identity for tan. Okay, so we know that tan square theta plus 1, tan square theta plus 1, right, is going to give you sec square theta. So we can write here or somewhere we need that identity coming there. So what I can do is tan square theta is minus of 1 plus sec square theta. That is what I can write. So I have here some similar term coming. So what I do now, minus of y by x sec y tan y is going to be, I'll write here plus of tan square y over y by x sec y minus tan y. Okay, now when you take tan y common, what do you get from the numerator? Or you can take minus tan y common. Okay, let's take minus tan y common. I get in the numerator y over x sec y, tan is gone common. Okay, so here I'll get plus okay, so I have taken minus sign common, so I'll get minus here, and here I get tan y. So, and it is in the denominator y by x sec y minus tan y. So what you see, this is getting cancelled, and finally we are with a nice answer, which is minus of tan y. Now this simplification when we did, okay, so we let this minus tan y is equals to g of y, and now we calculate if. When we calculate if is what? E to the power integration of g of y dy. So this gives me e to the power integration minus of tan y dy. Now I had also told you last time, whenever you are recalling the integration of tan and all, you can just write this directly, that it is e to the power minus the integration of log of sec y. Okay, and this is basically, oh sorry, answer we have to write so that integration sign is gone. And now here you have here when you have this minus the log of sec y, so it becomes e to the power log of cosine of y, and this is cosine y. Okay, so you have got cosine y in the term, so you multiply this, multiplying if to the given differential equation 1, we get when you multiply cos y, what will you get? Y over x cos y sec y. Okay, minus, then there is tan y into cos y. This is what we get with dx. And then there is cos y into sec y. Okay, into log x is also there, right? Log x minus cos y into x dy equals to 0. This is the differential equation. Now we simplify this, so it is y over x minus sin x, sin y over here dx. And here what do we get? Cos y, this goes away, cos y log cos y sec y becomes 1, and log x minus x cos y dy. Now we will compare this with comparing with m1 dx plus n1 dy. Okay, when we compare this with m1 dx n1 dy, what do we get? We'll get some answer. So m1 is equals to y over x minus sin y, and n1 is equals to log of x minus x cos y. Therefore dabba m1 by dabba y, when you calculate, what do we get now? It is 1 over x, derivative of sin x is cos. Okay, so here you get cos y. Now what about this one? Dabba n1 by dabba x, when you do it, is 1 over x, and the derivative of this is cos y, which implies dabba m1 by dabba y is equals to dabba n1 by dabba x. Thus here the equation 2, hence we can say 2 is exact. DE. Now the moment it is exact DE, we are in a position to write the general solution for 2. Of 2 is, we'll write the general solution of 2 as integration m1 dx y constant plus terms of n1 free from x dy equals to C. I hope you are following this. If you are following, just hit thumbs up in the in the chat section, so that I can get a overview of this. Now see, it entirely depends upon the differential equation, that how complicated the terms come into the picture. I cannot predict here anything, I can just give the method. The whole complication is depending upon what kind of function the question gives you. Okay, so yeah, let me know if you have any difficulties, then we can handle it. You can put your difficulty in the comment section. So here now you have, when we are going to integrate this, it is integration of y by x minus sine y, right, sine y by dx, treating y constant, and terms of n1 free from x. Now anything that is free from x we have to take, so n1 has nothing free from x, so here it is 0 dy equals to c. Now let us integrate. Y is constant, 1 upon x, integration is log x. Okay, integration of sine y, integration of sine, see, sine derivative is cos and cos derivative is minus sine, so integration of sine is going to be minus of cos, so minus of cos here equals to c. Now y log x plus cos y equals to c is our answer in this. Okay, oh sorry, I made a mistake here. We are not integrating with y, we are integrating only with x now. So here what you will have is, you will have here is y over x, integration is log x, sine y integration is only thing that you will get is x sine y. Okay, so your answer is x sine y, final answer. So that is your final answer here, and yeah, so this is the general solution. This you get your answer. Now when you are doing this, be very careful. See, like, I have to manage things here while calculating, check the other screen on my side and everything accordingly, so I just got distracted. So but you please stay focused and see to it that you are you know, in the full-fledged mode and follow the thing properly, because here when you are integrating with respect to x, y is treated as constant. Don't integrate y terms also, okay, like how I did here. So just be very careful. So this is one question on our one of the types that we see. Let us take up another question now, where you get another things happening there. Let us see another kind of question where we have to, you know, handle more complicated terms given to us. Yeah, let us see this. This is a good question according to me. So see here, x sine x dy plus y times x cos x minus sine x minus 2 dx is equals to 0. Now this is a very very important question. Please mark this important, because it has a certain different thing coming into the picture. Now let us see how to handle this again. First we will write down the differential equation. So x sine x dy plus y, I'll write here as yx cos x there is some error in the question. Just a minute, I'll take this here in this way. um, okay, let's do this. No, it's correct. Minus y sine x minus 2 dx equals to 0. So m over here is x sine x, and n over here, oh no, m is, just a minute, wait a minute. Now we write this in the standard form first. So the standard form here is yx cos x minus y sine x minus 2, you write this here dx, plus x sine x dy, you write equals to 0. Now therefore m over here is y into x cos x minus y sine x minus 2, and n is going to be x sine x. Okay, so this is your m and this is your n over here. Now when you calculate dabba m by dabba y, when you go for calculation here, so what you get is x cos x, okay, and minus sine x, and the 2 goes away, and dabba n by dabba x, when we calculate, we will get x into cos x plus sine x over here. Now let us calculate the quantity dabba m by dabba y minus dabba n by dabba x. When we calculate this quantity, so it is x cos x minus sine x minus x cos x plus sine x. Okay, now when you do this calculation, what you see is minus this here you will get here, I'll write this thing here down. So x cos x minus sine x minus x cos x minus sine x. So this gets cancelled, so minus 2 sine x is the quantity that you get. Now with what should we divide? We cannot divide with capital M, we will have to divide with capital N, because you will get a function of x alone over there, right, in that case. So therefore dabba m by dabba y minus dabba n by dabba x over capital N, when you do, you will get minus 2 sine x divided by, you have n is x sine x. Okay, and then this will we can cancel. Okay, and you get here minus 2 over x. Now if, when you do if, is this is f some function of f of x, right, some function of x. So here you will get e to the power integration f of x dx. When you do, you get that, and then it is e to the power integration minus 2 by x dx. So this is e raised to, what you get is minus 2 log of x. So this is e to the power log of x raised to minus 2, that is x raised to minus 2 is the answer over here for our integrating factor. Now we multiply we multiply if to equation number 1. Have we labeled anything equation 1? We haven't. So we label this equation number 1. So when we multiply this x raised to minus 2 to the equation number 1, what happens? Let us see. To 1 we will get here the first term we will get here is y x sine no yx cos we had, okay, yeah, yx cos of x minus y sine x minus 2. So this term is getting multiplied by x raised to minus 2 dx, and then there is x raised to minus 2 multiplied by x sine y x sine x dy equals to 0. Now let us simplify this. So it is y over x cos x minus y over x square sine x minus 2 over x square. Okay, this is over x square, and dx, and here it is sine x over x dy equals to 0. Yeah, this is the differential equation that we get. Now when you see this differential equation, we now have to be very careful over here. See, if we use the first formula, so we will have to first even check whether this is an exact dE or not. So therefore m1 is y over x cos x minus y over x square sine x minus 2 over x square, okay, and n1 over n1 is sine x over x. So let us calculate whether we get dabba m1 by dabba y. So what do we get? We get dabba m1 by dabba y is cos x by x, right, and then it is minus sine x by x square, then it is that minus 2x square is gone, dabba n1 by dabba x. When we try to do this, here it will give us sine x over minus of 1 upon x square plus 1 upon x into derivative of sine x is cos x. Okay, so this is what we get, and hence we say that dabba m1 by dabba y is dabba n1 by dabba x, which implies this differential equation 2 implies 2 is exact dE, and hence sorry, yeah, 2 is exact dE. Now while writing the solution, so see, generally here with the solution we write as m dy m dx here with y constant, right, and here terms of n free from x dy equal to c. Now let us see what happens if we keep this formula and try to do. See, when you want to integrate here, you get y over x cos x and all that. Now this integration, when you want to do cos x over x integration, this is slightly difficult for most of the students. Okay, you won't get the answer easily. So instead of using this formula, what we can do, we use the alternate version, the which we have got. Okay, so we use the second version of the formula, because integration of cos x over x is a troublesome thing for us at the initial stage. So what we will do, we will rather write the formula other way round. So we will integrate terms of m1 free from y dx, okay, plus terms plus n treating x constant. This version is an easy version over here. That is why here this will be helpful. So what happens in this case, m1 terms that are free from y is only minus 2x square. So minus 2 over x square we integrate with dx. This is doable. And here we have to treat x constant. So terms of n1, which n1 rather, so here they are sin x over x. Now everything is constant, so you don't have to worry. Okay, so here when you integrate, it is minus 2 x raised to minus 2 plus 1 over minus 2 plus 1. Okay, this is the integration, and sin x over x is constant, so it comes out, and here you get y equals to c. Hence my solution becomes minus 2 into x raised to minus 1 over minus 1 plus sin x over x equals into y equal to c. So therefore we have here 2 over x plus y sin x over x equals to c. This is the answer. Okay, so be very careful in this kind of questions, because some of them are very different, some of them are very easy, some are tricky. So this is what I had you for like, this is what I wanted to tell you people, to understand the main thing, that while solving there can be lot of different things coming into the picture, and some are very straightforward differential equations, some are very much twisted. You have to gain a lot of practice over them. Once you gain the mastery, you are free to solve it anyhow the way you like. But anyhow, I mean to say, whichever method suits to the problem, that you can try. But later on what happens is, you have to develop that skill to identify the the question for which it has been made up for. So let us see one more question related to similar thing, and we can solve that. So let us see an easy version now. So we'll see this over here. Now what is there is, yeah, we see an easy version of the same. So let's say we are given to solve y dx minus x dy plus log of x dx equals to 0. How to handle this? Let us see. First you collect the dx terms. So y plus log x dx minus x dy equals to 0. So here you have m equals to y plus log x and n is equals to minus of x. So dabba m by dabba y is equals to 1, right? And dabba n by dabba x is minus 1. So dabba m by dabba y minus dabba n by dabba x, it's obviously not equal. I'm not writing all that whether it is exact or not exact. So it's obviously not equal, but it is visible. So 1 minus of minus 1 is 2. And now you want something which is going to give you a nice integrating factor. So it is clearly visible here that dabba m by dabba y minus dabba n by dabba x, I have to divide by capital N. So 2 over minus of x, so that is minus 2 by x is the thing. And now when I go for calculation of if, it is e raised to, if I call this as f of x, then again it is integration e raised to f of x dx, e raised to minus 2 by x dx. If I have to do, I'll get here x raised to minus 2 as the answer. Okay, just the same one that we had got here. So now when we integrate, we have got the if over here, so we multiply this if to the equation number 1 and you get a new dE. Therefore multiplying if to 1, we get here, well, what do we get? Let us see. X raised to minus 2 into y plus log x dx minus we will get here is x raised to minus 2 into x dx. Okay, so here it is y plus log x divided by x square, and this is dx, and here you will have minus sorry, here it is dy, and here it is, I'll just erase that and write it, dy equals to 0. So here you will have 1 over x dy equals to 0. Okay, now we have to check whether it is exact or non-exact. So therefore m1 is y plus log x over x square, and n1 is minus 1 over x. So dabba m1 over dabba y, let us see what does it give you. It gives you 1 over x square. Okay, and dabba n1 over dabba x gives you 1 over x square again, in n1, that also gives you x square. So if I call this as equation 2, so therefore 2 is exact. dE. Now, having said that 2 is exact dE, general solution of 2 is integral m1 dx y constant plus integral terms of n1 free from x dx. Okay, sorry, no, x dy equals to c. Now see this, if we try to do this again over here, I would like to tell you that, see, if we do this y plus log of x over x square, again a difficulty is going to come while doing the integration. Log x over x square, when we try to integrate, it is going to create a havoc for us. So like, yeah, you will need substitutions and all that, why to land up in that kind of zone. And if I integrate terms of n1 free from x, if I do, what I will get is here that n1 is minus x, nothing is free from x. Okay, so here I get 0 dy equals to c. That is one way out. Now it is upon to us. If you want to take that way, that is also fine, or you treat terms of this free from y, that is another way you can get it done. I would suggest that better do that terms free from y, and then if you get that, you will get the answer faster. Or both the ways, it is going to give you the same, but then you have to be very careful while choosing the formula. So I'll do this here. See, when you have y over x square plus log of x over x square dx, okay, so here when you are going to integrate, treating y constant, you will get here all throughout you are going to integrate. So y is constant, x raised to minus 2 plus 1 over minus 2 plus 1. Okay, now what about this one, log of x over x square dx, when you have to integrate? So it is equals to c. Yeah. Now when you have this, you put the substitution, put log x equal to t. Okay, put log x equal to t. Then what you have after that is, let me write here, I'll write in the steps, it would be better thing, I guess. Okay, so here it will be y into x raised to minus 1 over minus 1, and here you keep this as it is. So minus of this. Now when you have this kind of integration, log x over x square dx equals to c, so you put log x equal to t, you get your answer. Here is e raised to t is equal to x, that is what you will get. And so derivative of log x is 1 upon x, t dt by dx if you take, So this also implies dx by x is dt. Okay, this is what you will get. Now considering log, if you just take log of x over x square dx, what all terms have vanished? Let us see. This has log x has got converted to t, dx has got converted to dx over x, right? So this rather I'll write here. First we write like this better: log x over x into 1 over x dx. Now we can get a better split. So log x has got converted to t, dx over x has got converted to dt. But what about this x? That x is still remaining, so that can be written as e raised to t. So here you have integration t into e raised to minus t dt. So when you integrate this, it is t e raised to minus t over minus 1. Then there is derivative of t is 1, e raised to minus t over 1. Okay, so your answer is minus t e raised to minus t and minus e raised to minus t. This is the answer for log x square. So now you resubstitute t. So what do you get here is you take e raised to first you take e raised to minus t common, minus t minus 1, and so this can be written as a minus of here you can write minus log x minus 1 divided by e raised to minus t is going to be 1 upon x. Okay, so this is your answer for your log x square integration. Therefore you have minus of y over x plus log of x over this rather minus log x minus 1 whole thing over x equals to c. This will be your final answer. You can simplify a bit more if you want, otherwise I don't think so there is any need of simplification. It will be just shifting the terms here and there. Okay, is the general solution. Now let us see another type here. Quickly we will see other two types and then we will wind up the lecture, because we are on the press of time, and we will see the other two questions quickly. Now see, all the questions that you see which are homogeneous, they can be solved by either of the method that you like, and there's no need to be scared of either of them. Okay, let us see how to handle the other one, which is here. There are a lot of terms are there and you have to be very careful with this, because these terms you know, they can bother you afterwards a lot while solving them, so you be very careful. Okay, so let us take up this question. So the question number that I had taken was 4. Now we go for 5th question here. So I'll take up this question here, which says solve. Now this was there for one of the examinations in one of the year, so it's a good question according to me, but then you be very careful. X cube y raised to 4 plus x square y cube plus xy square plus y dx plus x raised to 4 y cube minus x cube y square minus x square y plus x. Now you see the formulation of the differential equation, it looks very gimmicky. Now in order to get this into the format of one of the differential equations, first you try to understand it very carefully, that everything is a function of y getting multiplied and then x getting multiplied, right? So let us see here. So this we can write here, y times x cube y square plus x square y square plus x y plus 1, right? And this is dx plus, now here I can write this as x cube y cube minus x square y square minus xy plus 1 equals to dy equals to 0. Now you see this, there is one small hint I would like to tell you. All this 1, the hint is 1 can be seen as x raised to 0, y raised to 0. Okay, so I can now claim, now we say that the given dE, given differential equation, is of the form, it is of the form, which one? It is y times f of x y, some function of x y, plus into dx plus x times some g of x y times dy equals to 0, right? This is how it is, some function of x y it is. So now we the m here, which is the entire function first, so here m is going to be the original thing, x cube y raised to 4 plus x square y cube plus xy square plus y, and n is going to be x raised to 4 y cube minus x cube y square minus x square y plus x. This is the m. So what you do here is you multiply x first, so this is x raised to 4 y raised to 4 x cube y cube, you know, in order to just get the powers alike. So x square y square plus xy, and here you multiply yn. So here again you have x raised to 4 y raised to 4, okay, and then here you will get minus x cube y cube minus x square y square, and then there is xy. This is what you get. Now first you check that quantity xm minus yn, is it equal to 0 or not, otherwise then we have to see something else. So let us see that whether does that become 0. No, it doesn't become 0. When you do the subtractions, you will see this x raised to 4 y raised to 4 plus x cube y cube plus x square y square plus xy minus x raised to 4 y raised to 4 minus, here it becomes x cube y cube plus x square y square minus xy. What remained and what left, we have to check. So what goes away is x raised to 4 goes away, then next is this xy goes away. Okay, so what is remaining with us here is basically 2 times x cube y cube plus 2 times x square y square. that can be simplified further to an extent 2xy taken common, and then or rather 2x square y squared can be taken common, and then I can write this as 2xy plus 1. Okay, so this is what I have got, and this is not equal to 0. This we will consider not equal to 0, and hence I can now write my if to be 1 upon xm minus yn. When I do this, I'll get 2x square y square xy plus 1. This is what I get, and then I have to multiply this if to the original differential equation. Now that's a big tough task, so be very careful, or you can get to that simplified version also, because it's not going to bother much. So when you see this, you be very careful here. So let us divide term by term and write it carefully, because it's big terms are there, and then now too much of back forth we have to do, so be very careful. So y multiplied by, I'll write the terms directly now. Y multiplied by, you have x cube y cube plus x square y square plus xy plus 1. Okay, we are going to divide this by 2x square y square times xy plus 1. Okay, this is dx, and then there is x multiplied by x cube y cube minus x square y square minus xy plus 1. Okay, dy divided by 2x square y square times xy plus 1. Now let us see what happens to this. See, y gets cancelled, so I can reduce it by 1 degree. So it is 2x square y xy plus 1. Now can you see in the numerator, from the first two term I can take x square y square common. So x square y square taken common, I get here x y plus 1, and here I'll get xy plus 1. Okay, so this is the big term under dx. Same way here also I can take x square y square common, but then there is this minus sign bothering us. Let us see what happens with that minus sign. If not getting cancelled, it will stay there and something else will get cancelled maybe. So let us see if we can take that way. X square y square remains there, and then I have xy minus 1 into the picture, minus of 1 taken common, xy minus 1, and then x is gone reduced, so 2xy square xy plus 1 dy, all this is equals to 0, right? So we are now multiplying, and then let us see what happens. So now in the numerator, what happens here in the first part is xy plus 1 can be taken common, and I get x square y square plus 1, and there is 2x square y and xy plus 1, which gets cancelled. Okay, with that. So, and over here what happens is a very nice thing. xy minus 1 taken common, x square y square minus 1 over 2xy square xy plus 1. Now what to do? This is very good gimmick of mathematics is that is happening, but yeah, you can, all this intellectual stuff that you do, it can be, all those school level identities that you have learned, they are put through here. So now what is this? This terminology is a square minus b square, right? So xy minus 1 will remain as it is. From this one I'll write xy plus 1 x minus 1 over 2xy square times xy plus 1 dy equals to 0. Again, you can now see this is getting cancelled. Alright, so that is what you get there. And now after this whole, xy plus 1 the whole no, I think xy, no, what was there, x square y square, yeah, it is. So we had here x square y square plus 1 over 2x square y, 2x square y dx plus, here you have xy minus 1 the whole square over 2xy square. That is what you are left with, and this is with dy equals to 0. Whew. This was quite a big solving for a differential equation that is very easy looking, but this is what you have to remember, that differential equations can look nice, they can look very good and easy going one, but then you have to be very careful while doing that. Okay, so now you have this, so this is your equation number 2. So m1 is x square y square plus 2x square y here, and n1 is xy minus 1 the whole square over 2x, this, okay, 2xy square. So you can expand if you want, x square y square minus 2xy plus 1 over 2xy square. So on simplification, what do we get here is x square y square over 2xy square minus 2xy over 2xy square plus 1 over 2xy square. Now this gets cancelled, so x by 2 minus 1 by y plus 1 over 2xy square. And here on m1 you will get y by 2 plus 1 over 2x square y. Now you check for dabba m1 by dabba y. So this is 1 over 2 plus 1 over 2x square, but 1 over y is minus of y raised to minus 2. Okay, so that is what you get there. And what about this one, dabba n1 by dabba x, when you do it is 1 over 2, that is gone, and then it is yeah, here you get 1 over 2x square y square with negative. So finally we can conclude, which implies that dabba m1 by dabba y is equals to dabba n1 by dabba x. yeah, so therefore 2 is exact. 2 being exact, we are now in a position to write its solution. So therefore integration m1 dxy constant plus integral terms of n1 free from x dy equals to c. Now therefore what do we do over here? Now when it is m1, terms are there which are constant, so y by 2 plus 1 upon 2 x square y dx. Y is constant. That is what we did. In terms of n1 which are free from x, now only term that is free from x is 1 over y, right? So, and that too with minus sign. So here minus 1 by y dy equals to c. So here when you integrate is yx by 2, okay, and now 1 by 2 integration of x square you have to do. Oh, and that y is constant, right? So 1 upon 2y is outside, so x raised to minus 1 over minus 1 you will get, and here you will land up with a minus of log y as the answer equals to c. Yeah, and then you just have to do some manipulations here. So y x over 2 minus 1 over 2 xy minus log y, oh just a minute, log y equals to c. Now see, this is your answer, not a big issue. You can simplify it if you wish, otherwise you can keep it the way it is, not a big problem. That is, it's not going to bother much in the solution either way. Okay, max what you can do, you if you want to, I would suggest then you can write yx by 2 minus 1 over 2 xy. Now this log c might plus log y it will become, right? And c can be treated as log of c plus log y. So this becomes here, it will become to you log of yc or cy, and then it is yx by 2 minus 1 over 2xy. So if you simplify this, yx by 2 minus 1 over 2xy equals to log of yc. I don't think so there would be any great chance of getting some extremely powerful answer out of it, but then finally only the format of your answer looks nicer. Okay, what I'll do this, I'll push this 2 in the log part, so it is 2 log cy, I'll write, that would be better, minus 1 over x, here also 2 will come then. Yeah, so if we do that, then we will get this way also. So this is the maximum you can do this much simplification. There is no need of simplifying further, but I'll just do for the sake of mathematicalness, or c square y square. So this is your final answer. either this way or the other way around. You can halt your answer here also. This is the answer. You can avoid, this can be avoided, avoid, can be avoided. Okay, so that's what is there on this kind of question. Okay, so now this is the kind of question that I uh, took. You can take any other on similar kind. Now let us see one question on homogeneous, and then we can stop our discussion for the day. Now it's very easy in a homogeneous case that almost everything can be solved by the method that you have already learned at your +2 level, and I don't see any difficulty. If you do that way also, you should be awarded your full marks. So let us see this here. X into x minus y dy plus y square dx is equals to 0. Now in this case you have your m as x minus y, and in the case n is, oh no, wait a minute, it is dy is given first, so always remember you have your format as dx as the first one. So x minus y into x dy equals to 0 when you put. So m is y square and n is x minus y. So here the differential equation is homogeneous, so we can try here with xm plus n yn. So when you do this, so you get x y square minus no plus, sorry, so here it is y into x minus y. So xy square plus y x square minus y square x. So this gets cancelled, so x square y is the output, and this is not equal to 0, and therefore you multiply this to your equation number 1. So what do we get now is this is your if basically. So if is x square y, and therefore multiplying if to 1, we get, what do we get? Let us see. Here you get is x square y square, and then there you will get x square y square dx, and here you get no, x square y cube, you will get x square y cube dx, and then you have here it is x cube y x minus y dy equals to 0. Now your m1 has become x cube y cube, and n1 has become x cube y x minus y. So let us simplify this. This is x raised to 4y minus x cube y square. So daba m1 by daba y is 3x cube y square, and n1 daba n1 by daba x. So what is this? 4x cube y minus 3x square y square. That's not becoming equal, right? Let us see what has gone wrong now. So when you multiply here, we will have to check what goes wrong also, because sometimes they may not land up into the correct part. So xy, the moment you multiplied here, you got that. Yeah, so that is your if. X square has gone inside, you x square minus y square, so xy, x square y square, x square y cube. Yeah, I have written here a mistake has happened, I guess. Yeah, yeah, in multiplication I think I'll do this erase. Yeah, so this has gone wrong. X cube y, so x raised to 4y, and yeah, so yeah, let us see now how to handle this. So 3y square x square, oh yeah, sorry, this is here, the thing here is it is x square y cube, okay, x square y cube, and then what we get here is let us see how to take up the derivative now. So it is 3x square y square, obviously. Now is this becoming equal? It is not becoming equal, so we have to be very careful while doing this. Or they generally, in most of the books, they have not even checked whether it is an exact differential equation even before you know, whether you take it up into the terms or not. They just whoosh, get it done. They have not even checked in most of the cases whether it comes down to be exact or not after even solving. So x cube y cube, when you get this, we have to now see whether it works for it or not. So x square y cube is this, and n1 is here, so x raised to 4 x cube y here. Yeah, so we get this, and it's not exact, so we cannot apply here that rule immediately just by taking and doing the differentiation. So now it's no longer exact. So what do you do now in such a case? So you check once more, so it's not exact, so you try to make it exact. So like you have the difference coming into the picture, now it is in the form of xy. So see, in such a case, either what you can do is rather than verifying this, you can not bother about uh, the verification right now, but what I'll suggest you, you take this m1 and because it is the integrating factor here. I'll just a minute, I'll get that thing cleared. Then it is an integrating factor, you multiply it, and then the solution, that is what they are saying. So if you solve this here, Okay, so we multiplied this if here. So the moment we multiplied this x square y into this term, so we got x cube y here, right? And then you got your n1 as x cube y x minus y. Now you integrate it. If you try to integrate for the solution, what is the solution saying is terms of x free from y and like that. So x square y cube, okay, y constant dx plus terms of n free from x, there no none is free from x, is equals to 0. So is equals to c rather. That is what you will get here. And now what happens, no, I think I have made a mistake here, that your if is not this. Wait, if is 1 upon, yeah, it is 1 over. That's why I was not getting the answer. I goofed up there. Just a minute, let's cancel this part. This is not the if. Yeah, okay. So your if is 1 over x square y. Okay, so the moment you multiply this there, what you get is multiplying if to the first part. When you multiply if to the first part, what you get here on erasing, I'll just erase that, and you get to 1, you will get your answer as x minus y over x square y dy. No, sorry, you get here y square over x square y dx plus x into x minus y over x square y dy equals to 0. This is what you get. Okay, now when you have this, therefore you have y over x square dx, and here you have x minus y over xy dy equals to 0. Now here you have this alone, so y over x square dx plus here you have 1 over y minus 1 over x dx, no, x dy, 1 over x dy over here, okay, equals to 0. Now you check, this is your m1 is y over x square, and your n1 is 1 over y 1 over y minus 1 over x. Okay, so dabba m1 by dabba x, sorry, dabba m1 by dabba y is 1 over x square, and dabba n1 by dabba x is going to be 1 over x square. So you have it exact. Dabba m1 by dabba y equals to dabba n1 by dabba x. You have it exact now, and now what you can do is you write the solution for that. So therefore the general solution is you have integration m1 y constant plus terms of n1 free from here m1 dx and here dy free from x equals to c. So the moment you do that, you will get 1 over here you have y over x square dx in terms of n free from n1 free from x, that is 1 over y. 1 over y dy equals to c. So y treated constant, so here it is y x raised to minus 2 plus 1 over minus 2 plus 1. Okay, and here it is log y equals to c. Now if you want to simplify this, you will have here minus of, here you have y x raised to minus 1 over minus 1 plus log y equals to c. So here you have y over x, and this is minus plus log y equals to c. Now what you can do is you can keep this way also, or if you want you can do a bit simplification, not much, but then this is your final answer. Yeah, you can just manipulate a bit more if you want. Like this will give you, you can push this minus sign on the other side, and then you can write this as y over x is minus log y equals to minus c, and you replace minus c by some another constant, c1 I can take. Okay, so now y by x is minus of log y equal to c1, so y by x is equals to c1 plus log y. Okay, and c1 can be treated as another constant, say log of c1 I can take, and log y is y by x. So I have y by x equals to log c1 plus log of y, right? And this can be now seen as c1y times log here. Okay, you have that log y by x over here, and therefore you have y by x c1y, and then there is this log here. So what you do with this log is e raised to y by x is c1y or some constant. So this is your answer. Okay, you can keep this answer or this also, both are correct, nothing is wrong in that. So just be very careful with this kind of questions, because I feel this kind of questions are good, but if you have a elementary method you are comfortable with that, then you can go with that method also. Okay, so thank you for joining in this quite a different kind of lecture for the first time. I have landed up with this live sessions happening from quite a few days, and those of you are benefiting from this, thanks. I hope they serve the purpose. Thank you. I will see you in the next video lecture. Thank you.